Hi, this is Pause Player from the GS Resources. For those of you who are regulars at the GS Resources, you know that I've been working on something I call the solid-state power box. So this is a little video to introduce the capabilities and features of this. This is a fully electronic replacement for your existing stock fuse box. It actually mounts in the same location. It provides 5 channels of solid state power and safe power, actually, because each of these 5 distributed channels is protected. And for example, if one of those channels becomes shorted, the device will recognize the high current situation, clamp that current, and if the high current condition persists, what will happen is the device will get hot. As it gets hotter, it also detects the high heat condition, and then it starts to pulse that current on that leg until it goes away, until the short goes away, in which case this restores itself back to full operation. During the short, you'll see a fault light come on. There will also be there's a green light that comes on when the ignition switch is turned on. So you'll have positive indications from the box of what's going on. The box will basically, as I mentioned earlier, will mount in the standard stock location. It comes either with a diagonal tab plate, as you see here. These are just simply painted versions of what's mounted on here. The older version of bikes, so the GSs, have these symmetrically tabbed fuse boxes. So you'll see there that you'll be able to mount even with an old style fuse box. Or another option is to get one of these tabless heat sinks, which actually bolts straight through, and you use a lock nut to hold it down. So we've got a fair amount of flexibility. You do need a heat sink because this will pull about 5 to 7 watts of power in order to distribute the power that's coming out of it. You see here's a picture that basically shows the solid-state power box mounted in the stock location. The primary connections are to the battery. Here you show a red primary wire running to a solenoid, or you could run directly to the positive side of the battery. Here's another primary that's connected to your rectifier regulator. This is something you'd probably directly solder. And there's a ground wire, but that's not the primary. That's not a ground wire where all the current runs through. It's just a ground reference for the solid-state power box. All the other connections for switches and power distribution are coming through a 10-pin Molex. Here I'm showing a wire running to the starter solenoid, which is one of the options to have the headlamp dim when you're starting up the bike. So. What I've got here to show you is one of the first prototypes that I put together. I've been using this to do all the testing to make sure that the device functions at the high and low temperatures and that the protections are all there. I integrated it with this production test set. The test set basically simulates what a motorcycle would do in terms of simulating switches. Through these 4 switches you see here, which would be ignition, kill, a start switch, and accessory, which can be either high or low. It measures the voltages on the 5 channels that come out. I have 2 additional voltage and amp meters that show the voltage and amperage that is coming out of my external supply. I've got a lab supply here, and then there's an additional voltage and amp meter to measure the voltage that's being applied to a load, a dummy load, which tends to stress each one of these channels, and I can do that independently. So just to give you an idea of really how this works, I'm going to turn on the power supply. So this really simulates the solid-state power box sitting there with your bike off, battery voltage is connected, and you'll notice now that my unswitched voltage is at 12.8 volts. If you can see that from the video. I can put a little load on this in case you say you want to have I'm not sure what you would have. You're running your Walkman or something, your iPhone. This is pulling 1 amp here. Not a whole big, not a large load on that, but this is capable of pulling up to 10 amps. I'm going to turn that off. So normally you would be sitting here. The unit draws about 2 milliamps, a very small amount. That's in addition to whatever you might put onto it, but regardless of what you put onto it, this only pulls 2 amps, so it's 2 milliamps, very small amount. Okay, so the basic function now that you'll see is when you turn your ignition switch on, is your signal channel, which is your brake lights and blinkers, comes on. Your headlamp will come on. I have the accessory configured to not be on at this point, but you'll notice that your ignition is not on. That obviously requires turning your kill switch on. Now you're ready to start the bike. You push the start button. You'll notice that the headlamp went away. Your bike is now started. Your start button goes off. Everything is on, and when your engine is running, the voltage goes up, and so I just turn the voltage up higher just so it's clear to everybody that we now have a running bike. We've revved it up a little bit, so we're running a little bit over 14.5 volts. Now the accessory can be turned on by going high. Again, I have this now jumpered. It actually has 3 options: high side control, low side control, and just simply coming on based on the ignition switch. So if I turn that off, again, it goes off. Just to show you the other option here, I'm going to re-jumper this real quick while you wait on me. Just takes a moment. Normally what you do is take the cover off and set these jumpers, and you only do this depending on when you wire your bike up, and you don't have to do it all the time. It's just whenever you decide what you want to do, if you want to have a horn control or whatever. So I'm going to go back and turn this on. So now remember, before when I turned it to 12 volts, it came on, and now it's going to the dropping the switch low means it grounds that switch, and so the accessory is coming on with a ground. So recapping real quickly: ignition switch off, kill switch off. You're now just having switch power. You turn your ignition switch on. Your headlamp comes on, your kill switch goes on, then the ignition comes on. You start the bike, the headlamp cuts out, and you want to turn on your accessory. This one's configured for a low side control, and it's on. So with these switches on the side over here, I can come in and put an additional load, and so you can see I'm pulling an additional 8 amps out of that signal, for a total of 12 amps out of the entire device. And I can do this on each one of these, adding that stress. I can even create a short condition, which will force that. You see the voltage dropped because of the short, but when I take it off, it goes back to normal condition. So the test box is turning out to be very valuable for doing a functional check, as well as a stress test on each channel to make sure that each channel meets the 10 amp requirement, and that it protects itself if you go beyond that. So hopefully this is a good little introduction on what the solid state power box is all about, so when you're reading the documentation, it won't seem so foreign, but you've got a really good idea about it. And I'll probably plan on doing some more of these videos to show the installs, depending on whether it's a replacement for an existing fuse box or to be integrated into a harness that might not have one. So hope to have these available by just after Thanksgiving of 2013, and hope to see you guys next time. Thanks.